you ever wondered how many atoms there are in the universe? Or in your body? Or even in a grain of sand? Scientists already have the answer to that question. They use moles. In this lesson, we are going to learn the concept of a mole and how moles are used in chemical calculation. In real life, if we want 12 eggs, we ask for 1 dozen eggs. Or, if we want 2 socks, we ask for a pair of socks. A mole is exactly the same. It's just a number, a massive one. 6.02 times 10 to the power of 23, to be precise. Imagine that if you took 1 mole of marbles, or 6.02 times 10 to the power of 23 marbles, they would not only cover the entire Earth's surface, but they would cover it to a depth of nearly 3.5 kilometers. The number 6.02 times 10 to the power of 23 is a fundamental constant known as Avogadro's number, or Avogadro's constant, in honor of the Italian scientist Amedeo Avogadro. In chemistry, we normally use the concept of a mole to represent atoms or molecules, because atoms are so small. 1 mole of any substance has 6.02 times 10 to the power of 23 atoms or molecules present inside it. In a half liter of water, there will be just over 25 moles of water molecules. 1 mole of water contains 6.02 times 10 to the power of 23 molecules of water. So, 25 moles contains 150.5 times 10 to the power of 23 molecules of water. So what exactly does 1 mole of atoms or molecules weigh? Well, this just depends on how big the atoms are. Just because we have the same number of atoms in 1 mole, it does not mean that they are all the same size. For example, you are probably aware that a gold atom is much bigger than a hydrogen atom, so 1 mole of gold will weigh much more than 1 mole of hydrogen. To calculate the mass of a mole, we use the concept of molar mass. Molar mass is defined as the mass in grams of 1 mole of a substance. The unit of molar mass is gram per mole. For atoms, the molar mass in grams is numerically equal to their relative atomic mass. For molecules, the molar mass is equal to the sum of all the atomic masses of constituent atoms. Anyway, why should you learn about the mole? Imagine you are working in a chemical plant. Your customer orders 100 kilograms of copper sulfate crystal. To deliver this, you need to dissolve copper oxide in hot sulfuric acid. But how do you know how much copper oxide is needed to add to the acid? With the help of moles and this simple equation, a problem like this can be easily solved. In this equation, the number of moles of a substance equals the mass of that substance in grams, divided by its molar mass. Looking at the chemical equation, we see that 1 mole of copper oxide reacts to form 1 mole of copper sulfate. So you can calculate the number of moles of copper oxide needed based on that of copper sulfate. Now, we need to know how many moles of copper sulfate are represented in 100 kilograms, or 100,000 grams of this product. The number of moles of copper sulfate equals the mass of 100,000 grams divided by its molar mass. Using the periodic table, you can work out the molar mass of copper sulfate, which is the sum of the atomic masses of 1 copper atom, 1 sulfur atom, 9 oxygen atoms, and 10 hydrogen atoms. It's 248.6 grams per mole. So, there are 402.2 moles of copper sulfate in 100,000 grams of this product. This is also the number of moles of copper oxide we need to add to the acid. Now we'll convert back to mass. The molar mass of copper oxide equals the sum of the atomic masses of copper and oxygen, or 79.4 grams per mole. So, 402.2 moles of copper oxide weigh 31,934.7 grams, or about 31.9 kilograms. Now you know that you need about 31.9 kilograms of copper oxide to produce 100 kilograms of copper sulfate. And that's how you use moles in chemical calculation.